So we have this statement and our job is to determine whether this statement is true or false. So for any integer n, if n is divisible by 6 and by 7, then it is also divisible by 42. So this is all about prime numbers. As we just learned, every integer greater than 1 can be expressed as a product of prime numbers. And the fundamental theorem of arithmetic states that this prime factorization is unique up to order of factors. So in other words, if we write 6 as a product of primes, there is basically just one way to do that. 6 is either 2 times 3 or 3 times 2, but that's pretty much it. Prime factorization is unique. So if a number is divisible by 6, that means it's 6 times something else, and that means that the prime factorization will have a 2 and a 3 and possibly other things in it, right? A number is divisible by 7 if it's 7 times another number, and that means that the prime factorization will have to have a 7 in it. So we have a number that's divisible by 6 and 7. That means that the prime factorization of this number will have to have a 2, have to have a 3 so that it is divisible by 6, and it has to have a 7 so that it is divisible by 7. And it could have other things. But the prime factorization of n must include these things. And if we multiply these things, we get 42 and possible other things. So that means that this number, if it is divisible by 6 and by 7, then it is indeed divisible by 42. And so this statement is true. Now that doesn't sound like an earth-shattering statement, but let's just see another example. It's a very similar statement. If an integer n is divisible by 6 and by 8, then it is also divisible by 48. Now let's see. So if we find a prime factorization of 6 and a prime factorization of 8, we will find that they share stuff, right? Both 6 and 8 are divisible by 2. So if we want to build up the prime factorization of n, in order to be divisible by 6, we have to have a 2 and a 3 in the prime factorization of n. And in order to be divisible by 8, we have to have 3 2's. Now there is just one prime factorization, so we have to have a prime factorization that does all this. So this is possible other stuff. So divisible by 6 means that the prime factorization will have a 2, a 3, and possibly other stuff. Now, how can we make sure that this same number is divisible by 8? Well, we need 3 2's. Now, this number is divisible by 6, and it is divisible by 8 because it has 3 2 factors in the prime factorization. But if we multiply these numbers, we do not get 48. 8 times 3 is 24. So n is 24 times some other stuff. So if a number is divisible by 6 and 8, then is it necessarily divisible by 48? Well, 24 itself is a good example. That is a good illustration that this statement is false. 24 is divisible by 6, it's divisible by 8, but it is not divisible by 48. So this statement here is false. Thank you for watching.